it's recording. All right, so let's talk about what an algebraic expression is before we even worry about evaluating it. All right, everybody ready to take some notes? So watch. Anything, even like a number, like 5, could technically be considered an algebraic expression. We probably wouldn't call it an algebraic expression, but it could be. Even just a variable, just a single variable, could be considered an algebraic expression. But here's the stuff that we're going to look more at as far as algebraic expressions. So I wrote a few down, so like x minus 3. That whole thing could be considered an algebraic expression. They're not equalities because it's not equal to anything, all right? It's just variables and numbers. They're being added, subtracted, multiplied, divided. Everybody settled in now? Okay. So these are considered algebraic expressions. You could have something like a fraction with a variable. That's an algebraic expression. You could have a couple different letters, something like that. That's an algebraic expression. You could have something like this, 3ab squared. That's an algebraic expression. Anything with variables and numbers, and you're doing stuff with them, right? You're multiplying it by something, adding it, subtracting it, dividing it, taking squares of it, taking square roots of something, right? That would be an algebraic expression. All these are algebraic expressions. What we're going to do is we're going to evaluate them. What does that mean? We're going to figure out what they're equal to, all right? We're going to throw some numbers in for the variables. We're just going to work it out, do the multiplication, do the addition, do the subtraction, whatever they ask you to do, and we're just going to come out with a number. So here's an example. This is example 5 because we're still on R-2. So we're down to example 5. So here's what it says to do. It says to evaluate each expression. I'm just going to say if, okay? But the book says evaluate each expression if x is equal to 3 and y is equal to -1. So this is what they're telling you, all right? They just tell you in the book that that's what x is equal to and that's what y is equal to. What you're going to evaluate is this thing right here. So you're going to figure out what x plus 3y is equal to. Does that make sense? So this is what we're trying to find. We're trying to find the value of that right there. You're like, well, I don't know what that is because I don't know what x is. I don't know what y is. But is that true? No, we do know what it is. They told us. They told us x was 3 and y was -1. So we're going to plug in. That's a word a lot of math teachers use. We're going to plug it in. We're going to take that value for x, and what are we going to do? Wherever you see an x, you're going to put in that value in for x. Does that make sense? So instead of x, what are we going to write? 3. And then you write the plus sign down. Now, what are these two things doing to each other, that 3 and that y? They're multiplying. So we go what? 3 times, you could put a dot for multiplication, but in algebra, what do we usually put for multiplication? We put a parentheses, and that's what we're going to do right here. So let's put a parentheses and put a y. So what is equal to y? Well, you come up here. They tell you. Y is equal to what? -1. So I put it right there. There's my x, that first 3. This is my plus. This is my 3y. And now I just work it out. Remember the other day we learned how to order of operations? We haven't had a quiz on it, did we? With order of operations. So what do we do first? Do I go 3 plus 3 is 6? No, I don't. I got to do the multiplication first. You got to do this first. So I just drop down that 3, and then it's positive 3 times -1. What is that? It's -3. So you could put plus -3. It's the same thing, isn't it? Plus -3 or just -3. It's the same thing. So what is 3 minus 3? It's 0, and that's my answer. So I just evaluated that algebraic expression. A lot of big fancy words, but pretty simple stuff, right? Just plug it in. Professor in college used to say plug and chug, and I said that for years and years when I teach algebra. Plug and chug, all right? Which means plug them in and then just work it out. That's the chugging part, okay? Just sounds cool because it rhymes, all right? So you plug it in and you work it out. Technically, I should probably put equal signs there because they're all equal to each other. Showed my work, right? I just didn't try to do it in my head. Put the numbers in, showed all my steps, and I got my answer. Let's do another one. Now you got the idea. So 5xy, that's my algebraic expression. I want to figure out what that is equal to if x is 3 and y is -1. So what are all three of these things doing to each other? They're all being multiplied. So watch this. This is what I do a lot of times. You don't have to, but where there's an x, I put a parentheses. Where there's a y, I put a parentheses. I kind of like to put that blank parentheses, and then I can plug the numbers into those parentheses. I don't know. That's kind of how I like to do it sometimes. So what am I going to put in that first parentheses? It's an x, so x is 3. What am I going to put in the second parentheses? Which is a y, which is -1. Now what do I do with all three of those things? Just multiply them together. There's no addition going on, so does it matter what order we multiply them in? No. Yeah, just multiply straight across. So 5 times 3 is 15. 15 times -1 is -15, and there you go. It's as easy as that. Let's do a couple more. How are we feeling about this? This one's a little bit more involved. You know they're going to be, right? They always start off with the easiest ones and they get tougher and tougher. So what do we do here? Well, there's an x right there. There's a y right there. So what am I going to put in for that y? First of all, I'm going to make it a blank parentheses. Oops. What happened there? Over 2 minus, then you got another 2. Then you got an x. What am I going to put in place for that x? A blank parentheses. Now I can go ahead and plug my numbers in. Everybody see what I'm doing? I just rewrote this, but instead of y, I put parentheses. Instead of an x, I put a parentheses. Now let's just plug stuff in. What do I put in for the y? I put -1 because they told me that y was -1. So I put a -1 right there. What do I put in for this? Whatever the value of x is. What's x? It's 3, so I put a 3 in for that. Now let's work this thing out. Let's do the top first. I only got to do one thing to the top. What's 3 times -1? -3 over, this is kind of like that first one. I don't go 2 minus 2, do I? I got to do this. I got to multiply them together first before I do any subtraction. So I'm just going to put that first 2 right there. Then I'm going to put a minus, and 2 times 3 is 6. It's super important that you do that. If you go 2 minus 2, that would be 0. 0 times 3 would be 0. That's not the same, is it? So you got to do the multiplication first, order of operations. A couple more things to do. Can't do anything else to the top. What about the bottom? 2 minus 6. Add the opposite, right? Remember, subtraction is adding the opposite. So I add the opposite. It's 2 plus -6. Subtract and take the sign of the bigger one. That's a -4. So 2 minus 6 is -4. Let's clean it up just a little bit. I'm not going to leave it like this. Why am I not going to leave it like that? What is it? I got 2 negatives. I got a negative divided by a negative. What's negative divided by negative? It's a positive. So I just write positive 3/4, and I'm good to go. And it's important that you do that, okay? Always simplify your fractions. Make sure you don't keep them both negative there. Okay? Let's do one more. D. All right, they throw something in here that we've talked about. See how all the stuff we've talked about is leading up to this? Right? We talked about order of operations earlier. We talked about absolute value earlier. Now we're putting it all together with this evaluating algebraic expressions. All right. I don't have it up here, but I think we remember now, don't we, what x and y are equal to? So I'm going to put the absolute value. I'm going to put a -4. Instead of x, what do I say to do? Put an empty parentheses there, okay? Plus y, I'm going to put another empty parentheses, and then close off the absolute value. Doesn't that look just like this, except instead of an x, it's a parentheses. Instead of a y, it's a parentheses. Now I can plug everything in. What did I plug in for x? What was x equal to? Do you remember what it was? is 3. So I just stick a 3 right there. What was the y? -1, so I put a -1 right there. Now I work this thing out. Keep the absolute value symbols. What am I going to do in here? Well, multiplication first, right? So I multiply them together. So it's -4 times 3 is -12. What's that? You could put plus -1, but what's the same thing as plus -1? It's just -1. So you could do that. A couple more things before we get our answer. Let's simplify what's inside the absolute value. So put the absolute value here. -12 minus 1. Remember how to do that? Minus means what? We add the opposite. Got the same signs. So when I add them up, I just add them up. 13, keep the sign, -13. But it's in absolute value. What does that mean if a negative inside absolute value? What do we do? Make it positive. That's right. So my answer is positive 13, and there we go. You've done this a bunch in your algebra classes, right? You did it in Algebra 1. We kind of did it in geometry. Kind of did. And then in Algebra 2, for sure, you did the stuff in Algebra 2. All right. Everybody good? All right. Let's change gears a little bit. We're going to talk about this word, and in upper level math, they talk about this word all the time. I don't know if you did this in Algebra 2 or not, but the word is called the domain. Do you remember that? Domain and range. Did you do that in Algebra 2? No? Yes? Nobody knows? Everybody's looking around? Did we? I don't know. Are those words familiar at all, domain and range? Okay. At least you've heard the words, right? In a math class? All right. Whether or not you know what it means, that's not what I'm asking. But you have heard it before. Yeah, you should. So I'm going to tell you what it means. It basically means, I'm not going to write out the formal definition. I'm just going to write it like this. This is not a formal definition. This is just a way that we can think about it. What are all the possibilities for x? What are all the possibilities spell that right? Possibilities. Or, I'll tell you what, under possibilities, I'm going to put restrictions. Sometimes we write it as a restriction. I'll show you what I mean in a second. I mean, this little thing, it's not really, it's really not a definition. It's just a way that we could think about it. What are all the possibilities or restrictions of x? And domain goes with x. We're not going to talk about this today, but maybe another day we'll talk about it. The range, remember I said domain and range earlier? The range goes with the possibilities. What are all the possibilities of, what do you think? Of y. Good. All right, but today we're just going to talk about x. So, for instance, what if I had something like this? Okay, what are all the possibilities or restrictions? 1 over x. What numbers am I allowed to put in for x and still come out with just a number? All right, sounds weird. Can I put in any number at all? Could I make x a negative number and it'd be a number? Give me a negative number. Give me an easy negative number. -2. Okay, so 1 over -2. What is that? It's negative what? Timmy, head up, please. It's -1/2, right? Is that a number? Is it a number? Yes or no? Is it a number? Is -1/2 a number? Yes, it is. It's a number. Come on. I'm getting a little frustrated. That was the easiest question I've asked all year. Is -1/2 a number? Yeah, it's a number, okay? So, can you put a -2 in for x? Yes, you can. Can you put a positive number in? Give me a positive number. 2, okay? Is 1/2 a number? Yes, it is. Is there any values for x that you cannot put in for x and it not be a number? What about 100? Can you put 100 in there? Yeah, 1 over 100. Is that a number? Yeah. What about 1,000,000? Can you put that in there? Sure. Can you put a fraction? I'm getting all choked up now. Can you put a fraction in there? 1 over 1/2. Yeah, that's still a number, because 1 divided by a half is the same as 1 times 2, which is 2. Is 2 a number? Yes, it is. So can you put a half in there? Yeah. So you can put decimals in there, you could put fractions in there, you could put negative numbers, you could put regular whole numbers, positive whole numbers. So can you put any number in for x that you want? What have we left out? We talked about negative numbers, we talked about positive numbers, we talked about whole numbers, we talked about fractions, we talked about decimals. What have we not talked about? 0. Can you put a 0 in for x? What's 1 divided by 0? Who's got a calculator? You got a calculator? Okay, get it out. I don't care if it's on your phone. Get it out. I want you to see it. Put 1 divided by 0 in your calculator. Somebody tell me what you get. Undefined. Okay, your calculator says undefined. Mine says error. Some calculators might say syntax error. All right, 1 divided by 0 right here. This is what we're putting in to your calculator. Anybody try it? Undefined. Okay. Mine says error, but it all means the same thing. So, can you put a 0 in for x? No. So, let's talk about that. What are all the possibilities that you can put in for x? You can put all the numbers except for 0. That's right. Okay, so your restriction is x cannot equal 0. So here's how you would write the domain. You would say the domain I'm going to write it pretty simple, but I'm going to show you a little more complicated way to write it because it's the way you're going to see it. So the domain are all the real numbers. There's a fancy way to write all the real numbers. Instead of writing all the real numbers, what's a fancy way we can write all the real numbers? Remember this? Remember that capital R with that little extra thing? That's all the real numbers. Except for, right, you could say that x cannot equal what? 0. So the domain could be any number at all except for x cannot equal 0. That's your domain. So you're telling the person, what numbers can you put in for x? Oh, you can put in any number. Well, wait a minute. Except for one thing. What's that one thing? You just can't put a 0 in for it. Make sense? What about this? Now that we understand that, check this out. What if I had 1 over x minus 2? Very good. You got it right away. You can't put a 2 in there. Why not? Because it would equal 0, wouldn't it? Everybody see that? All right. Can you put a 0 in for this? Can x equal 0 for this? Sure it can, because 0 minus 2 is negative 2. 1 over negative 2 is a number. Okay, it does come out to be a number. Make sense? But what is your domain? It's every single number except for what? 2. And how did you get that? How did you know it was 2? Because watch what we do. Everybody look up here. Because sometimes it'll be a little bit more complicated than this right now. So what we're going to do, we're going to say that x minus 2, that whole denominator, cannot equal what? 0. So let's find out what x is. How would I solve for x? Add a 2 to both sides. So what can x not equal? X cannot equal 2. Okay? So anytime you have a denominator, that denominator cannot be 0. Does that make sense? Okay. That's good enough. Let me do a couple things. I got 5 minutes, probably 4 minutes. So let's move on. Example 7. It's the circumference of a circle. I'm not going to go into a lot of great detail with this. We talked about a lot of this in geometry when some of you guys, not everybody, had me. But let's talk about the circumference of a circle. So the distance around the circle is the circumference. So if I had a circle right here and I wanted to walk all the way around the circle, let's say I started here and I wanted to walk all the way around the circle and end up where I started, that's the circumference of the circle. We have a formula for that. We'll use c for circumference, and it is 2 times pi times r. What do you think the r stands for? The radius, okay? So twice the radius. Do you remember what the radius is? The radius is that right there. Or here's another way you could write it. You could write it circumference is equal to pi times, what is double the radius? No, not double. It's 2r, but what is that? What is that from here to here? That's the what of the circle. That's the diameter of the circle, okay? So you could write pi times the diameter. All right, so they're going to give you a simple little question. They're going to say something, they don't even have an example for that one. So I'm going to go to the next thing just because of time. But here's what they could give you. They could say, okay, the radius of the circle is 5 inches. Tell me what the circumference is. So what would you do? Come up with a formula. What's the formula? 2 pi what? R. So they tell me the radius. So it's 2 times pi times the radius. What's the radius? It's 5. So let's do some math. 2 times 5 is 10, and 10 times pi. What is pi? Right. Pi is approximately 3.14. So you could go 10 times 3.14, which is, I should put approximately, 31.4, and it's in inches. That's how you would do circumference. One last thing. We're going to do a conversion from Fahrenheit to Celsius, okay? We have some students in here from Spain, right? And not in this class, but in some of the other classes. You've seen them around, right? You've seen the Spanish kids around. And they really don't know what the temperature is in Fahrenheit. If you said, well, it's 72 degrees outside, they're like, I don't know what that means. And you wouldn't know what it meant. If I said it was 20 degrees Celsius, you probably wouldn't have any degree if that's hot or cold, would you? All right, so you got to be able to convert. Now, with phones nowadays, you can just put it in your phone and do a conversion just like that. But I'll show you a formula. You ready? Here it is. So what do you think the C stands for? Celsius. What do you think the F stands for? Fahrenheit. So let's just do that number. Let's say it's 72 degrees outside. And I wanted to tell some of my Spanish friends what the temperature was so that they would understand what that means. What would you do? What math would you do? Well, you go 5/9 and you plug in, right? Evaluate, that's why we did that earlier. You plug in a 72 in for Fahrenheit. So what is that? 72 minus 32. Let's do the math. That's 5/9 times, what's 72 minus 32? That'd be 40. And now you just do the work. It's 5/9 times 40, or just 5 times 40. What's 5 times 40? 200 over 9. I have no idea what that is, so I'm going to put that in my calculator. So 200 divided by 9, and that's 22.2, approximately. 22.2 what? Degrees Celsius. And usually with Celsius, they put Celsius degrees. It doesn't matter, I don't care. All right? So if you told somebody, well, it's 72 degrees outside, that means it's 22 degrees Celsius. So that's always nice to know. But nowadays, you got a phone, so you don't have to worry about that too much. But here's your homework. This is your second R-2 homework. So what are we going to call it? We're going to call it B. So you're doing page 27. And 39 to 71 seems like a lot, but guess what? I'm only giving you the odds. So there it is. So you won't have class until what? Thursday? All right, so this will be due on Thursday. So make sure you get it done. And don't say, well, I was at the retreat, da-da-da-da-da. I mean, you're going to have almost all of Wednesday to yourself. All right, so you got time to do this.